Okay, so today we're going to do some antiderivatives and integration. And to do so, let's consider the power rule. Let's do some derivatives first of all. If I was going to do the derivative of this one, recognize I'm just going to go dy dx. And again, it's going to be 3x squared minus 8x plus, well, that 1/2 power comes down, so it's 3 over 2 x to the minus 1/2, doing that in my head, plus 0, because that just goes away. When I do to this one, dy dx, I look at this and I get 3x squared minus 8x plus, again, the 3/2, x to the minus 1/2, and the 34 goes away. And so what I notice is like these derivatives are the same, yet the functions were a little bit different just by this constant term at the end. And so that's an important aspect to consider, because if I go the other way around, imagine if I want to work backwards now. Imagine I'm given this function dy dx, and I want to go to find the original function. Well, then I would go well, if I was going to go here, the 3x squared, this 3 had come down. So I look at the 2, I actually add 1 to it, and that 3 would come up. Minus, well, this x, I have to add 1 to the exponent, as opposed to subtract when I add 1, so that'll be 2. And I have to counteract that, so I'm going to divide or multiply by the reciprocal of this exponent I've added, so multiply by 1/2. And I'll write that out a little bit nice right here. So that 8 is going to be multiplied by the 1/2. And if I look here, again, I'm going to add 1 to my exponent, so that'll be 1/2. I have my 3/2, and I multiply actually by the reciprocal of this. So the reciprocal of 1/2 is 2. And then I have to consider all these values that would be at the end, and so I have to just go plus c. It could be any number at the end, and so I just put a constant there. And if I simplify this, I get x cubed minus my 4x squared plus 3x to the 1/2 plus c. And I can see that I ended up with exactly the same functions that I started with if I do it backwards. And so this highlights what's actually quite important for us. It's antiderivatives, okay? And so what we're doing is we're finding the antiderivative of a derivative, okay? It's also called an indefinite integration, and it's notated by this integral sign. And here is, if f of x is the function I'm integrating, big F of x plus c is my indefinite integral of f with respect to x. This is what we get. And we've also had another, we called this symbol an area symbol earlier, and soon we're going to put these two ideas together next class. So let's consider, so if this is my function, well, what happens though if I'm told though that this original function goes through this point? Well, I'm referring to this, I know then that I can just plug this point in. I know that my y value is 2, so I get 2 is equal to 0 cubed minus 4 to the power 0 squared plus 3 to the 0 to the 1/2 plus c. And so I get c is equal to 2 because these I'll cancel. And so if I'm given this initial point or a point that's on the curve, then I can find my full function. And so now I end up with 4x squared plus 3x to the 1/2 plus c. And so the key to antiderivatives, if I want to find the actual c value, the constant at the end, I need a point to plug in. Otherwise, I just put point c. So in your formula booklet, you'll find this idea of the power rule, that when we have to go backwards. And so if I'm going to look at this one, I'm going to integrate this. I look at my x cubed, I add 1 to the exponent, and I divide by the reciprocal, which is going to be that 4. This one here, I add 1 to the exponent, I get 2, which is a 2 that belongs there, plus I'm going to add an x plus c. When I consider this one, I have x to the 1/2. I haven't not doing the integration, so I'm being careful with my notation. Okay, and I'm going to rewrite this as x to the minus 1/5 dx. And so just because I'm rewriting it doesn't mean I have to keep my integration symbol, so I'm careful with it. And so now my coefficients up front I have to be a little bit more careful with. I always start with the exponent. I'm going to add 1 to the exponent, which is 3/2, and I'm going to multiply by the reciprocal, okay, which I actually did here. If I had the 4 and multiply by the reciprocal of this, 1/4, they canceled out to get the 1. All right, and so we multiply by the reciprocal of the exponent. And so now I get minus 2x. I add 1 to my exponent, 4, and I multiply it times the reciprocal. Plus, well, I'm going to add 1 to the exponent. If I add 1 to -5, that's -4. And I multiply by the reciprocal, -1/4 times the 1/4. And so I have to be careful of my negative signs, plus c. Simplifying that, I get 2/3 x to the 3/2 minus 1/2 x to the 4th. And then minus, keep track of that minus sign, 1/16 x to the minus 1/4 plus c. And you can always check to see if you're right by taking the derivative. If you take the derivative and you end up with this, then you know you've done it correctly. We'll try a couple more problems here. Now when we look at this one, this is quite complicated. So in order to find the antiderivative, I have to do some algebra first. I have to simplify it. So I have x squared. Well, this is x to the 1/5 dx. And I'm going to bring these x's together using, so x squared plus 1/5, well, that is going to be, well, 2 is the same as 10 over 5. So it's actually x to the 11/5 dx. And so now if I'm going to integrate it, I add 1 to my exponent, which is going to be 16 over 5. I have my 3, and I multiply by the reciprocal of my exponent, which is 5 over 16. And so my final answer is 15 over 16, x to the 16 over 5, plus c is my antiderivative. Similar when I have this one, in order to do this one, I have to actually multiply this out and simplify. So this is going to be x squared plus 4x plus 4 over x to the 1/2 dx. And then when I put this together one more time, this x to the 1/2 belongs to all 3 terms. So this is going to be x to the 3/2 plus 4x to the 1/2 plus 4x to the minus 1/2 dx. So taking the integral of this, again, I start here, I add 1 to my exponent, multiply by the reciprocal, plus the 4, I add 1 to my exponent here, so that's going to be 3/2, and I multiply by my reciprocal, plus 4, I add 1 to my exponent, that's going to be 1/2, and I multiply by the reciprocal, which is 2 plus c. And so now I get 2/5 x to the 5/2 plus 8/3 x to the 3/2 plus 8x to the 1/2 plus c is my antiderivative. And so there's our introduction to finding the antiderivative of